All right, welcome to The Explainer. Today we're tackling something huge, artificial intelligence. It's a field that is completely reshaping our world, but man, is it filled with confusing jargon. So our goal here is simple, to give you a quick and essential guide to the terms you really need to know. Let's jump in.
You know that feeling, right? You're trying to read an article about AI, and it feels like you're trying to decipher some kind of ancient secret code. Well, trust me, you are definitely not alone. The language can feel super complex, but the ideas behind it, they're actually something we can all get our heads around. And that's exactly our mission today. We're going to decode it all together, piece by piece. To do that, we're leaning on a fantastic guide from Virtualization Options LLC, which is a Colorado-based tech research and advisory firm. They did the hard work of demystifying over 50 of these key AI terms.
Okay, so where do we even begin? Let's start with the big one, the term that kicked this whole thing off, artificial intelligence itself. So what does that actually mean? Well, stripped down to its core, AI is really just the broad science of teaching computers to do things that, until now, have required a human brain. You know, things like solving puzzles, learning from past mistakes, or even understanding language. Now, inside that giant field of AI, there's a really important piece of the puzzle. It's called machine learning, or ML. And honestly, this is the engine that drives almost all the AI you hear about today. This is the crucial part. It's where the system learns on its own, not by being programmed with a million rules, but by finding patterns in data all by itself.
And this slide just nails the difference. Think about it like this. Traditional programming is like giving a computer a super detailed recipe. You write out every single step. But machine learning, that's like giving the computer all the ingredients, showing it 1,000 pictures of a perfectly baked cake, and saying, you figure out the recipe. It's a total game changer. All right, let's peel back another layer of this onion. When you hear people talking about the most powerful, most advanced AI systems out there, they're usually talking about deep learning. This is a special, really potent type of machine learning that uses something called neural networks. And what's cool is that they're literally inspired by how our own brains are wired.
So how in the world does one of these things actually learn? Well, imagine you're teaching it to recognize a picture of a cat. The very first layer of these artificial neurons might just learn to spot simple things, like basic edges or colors. The next layer up takes those edges and starts to recognize simple shapes, like an ear or a whisker. And then a deeper layer puts all that together to form the final idea of cat. It's learning in layers, from simple to complex.
Okay, so we've got the concepts down. AI, machine learning, neural networks. But what's the actual process? How does an AI go from, knowing nothing to becoming a trained expert?
It really comes down to these three key parts. First, you need fuel, and that's your massive amount of training data. Then you need an engine to process all that fuel, and that's your algorithm. And what do you get at the end? The finished product, the car that's ready to drive. That's your trained model.
Right, so that model, that's the thing we're really talking about. For all intents and purposes, it is the AI. It's the brain that has soaked up all the patterns and knowledge from its training, and now it's ready to go out and make smart predictions or decisions on brand new stuff it's never seen before. But here's the thing. That model is completely useless without its fuel. And that fuel is the training data. An AI is only going to be as smart or as unbiased as the data it was raised on. For instance, a medical AI can't possibly learn to spot a rare disease unless you feed it thousands and thousands of medical scans that have been carefully labeled by human experts. The quality of that data is absolutely everything.
All right, so let's connect all these foundational ideas to the tech that's absolutely everywhere right now. I'm talking about generative AI and those large language models, or LLMs, that power tools like ChatGPT.
And this is a huge shift in thinking. See, most of the AI before this was about classifying things, telling you if an email is spam or not spam. But generative AI, it creates. It's the difference between an AI that can recognize a song and an AI that can compose a brand new one. And the stuff it can create, it's just mind-boggling. We're not just talking about answering a question. We're talking about writing entire essays, generating stunningly realistic photos from just a few words of text, or even composing a whole new piece of music.
So what's the secret sauce that makes these large language models so incredibly powerful? It's one word: scale. You can think of a parameter as a tiny little knob that the AI can turn and tune as it learns. And the biggest models today don't have thousands or millions of these knobs. They have over 1 trillion of them. It's a staggering number to even think about.
But, with all this incredible power comes some pretty serious responsibility. Building these things isn't just a technical challenge to make them smarter, we also have to figure out how to make them safe and fair. So let's get into the risks.
Okay, let's talk about a couple of the most common ways these models can go wrong. It's kind of like studying for a test. A model that overfits is like a student who just memorized the textbook word for word. They're useless on any question that's even slightly different. On the other hand, a model that underfits is like the student who didn't study at all. It's too simple and gets everything wrong.
But there's another flaw that's way more serious than just a technical glitch, and that's bias. This isn't just a bug in the code, it's a reflection of our own society's problems. It's what happens when the AI learns the hidden prejudices in the data we give it, and then it doesn't just repeat them, it amplifies them.
And the guide from Virtualization Options we're using gives a really powerful and, frankly, disturbing real-world example of this. If you train a facial recognition AI, mostly on pictures of white men, it's going to be far, far less accurate in identifying women or people with darker skin. And those kinds of failures have very real consequences.
So because of risks just like that, there's this whole new focus on how we build and use AI responsibly. It's a whole field dedicated to ethics and safety.
The whole idea here is to make sure the AI we build actually reflects our best values. It comes down to these 4 key pillars: making sure our models are fair, that they're explainable, that someone is held accountable for them, and that they're built to be safe.
And one of the most important ones you'll hear about is explainability, sometimes called XAI. This is all about fighting the black box problem. We need to be able to look the AI in the eye, so to speak, and ask, why? Why did you make that decision? This isn't just about curiosity. When you're talking about a medical diagnosis or a loan application, it's an absolute must.
And all of this brings us to one last really big idea to leave you with. Everything we've talked about today, from ChatGPT to a self-driving car, is what we call artificial narrow intelligence. It's an AI that's amazing at one specific job. But the ultimate goal for some researchers is something else entirely: artificial general intelligence, or AGI, a machine that can think and reason as flexibly as a human. So the real question to chew on isn't just if we'll get there, it's what happens when we do.